everyone, and welcome to the second half of section 5.1, angles of triangles. Today we are going to be finding angle measures within triangles. And in order to do that, we need to first define interior angles and exterior angles. The interior angles are inside of a polygon. So they are the ones that are enclosed in the inside of that polygon. Exterior angles are angles that form linear pairs with the interior angles of a polygon. So essentially, if you take each side length of a polygon and extend it out and look like you're forming something like a pinwheel essentially, you will be creating those exterior angles. So this blue angle here and this interior angle here form a linear pair. So these blue angles are our exterior angles. With triangles, we have three interior angles. And the sum of those interior angles is always 180 degrees. So the triangle sum theorem says the sum of the measures of the interior angles of a triangle is 180 degrees. Through this picture that says that the measure of angle A, which is this, plus the measure of angle B, plus the measure of angle C will add up to 180 degrees. We have an example here, and it is asking us to find the measure of each angle. We have 4 different angles here that it's asking us to calculate. We know, based on the triangle sum theorem, that angle A plus angle B plus angle ACB are going to add up to 180 degrees. So let me write that out. And now we're just going to substitute in the values that we have in those angle measures. So measure of A is 7x minus 11. So let's go ahead and write that down. 7x minus 11. Angle B is 5x minus 2. So plus 5x minus 2. Let's go ahead and put these in parentheses so you can differentiate them to start. And then ACB is 2x minus 3. And this all adds up to 180 degrees. We can essentially drop these parentheses and even the degree symbols to make your algebra a little bit easier to understand. So we will have 7x minus 11 plus 5x minus 2 plus 2x minus 3 equals 180. We need to collect our like terms. So we have a 7x plus a 5x. So 7 plus 5 gives us 12 plus 2 more x's. So that gives us 14x. We have a negative 11 plus a negative 2. So that's negative 13. Plus a negative 3. So negative 13 minus 3 is negative 16. And that equals 180. We're looking to solve for x, so we need to get x by itself. So let's add 16 to both sides. We end up with 14x equals 196. Divide 14, and we get x equals 14. So this becomes an important number because we're asked to find the measure of each angle. So now we need to substitute the x back into each one of these. I went through and wrote down the equation that we need to calculate each angle measure here, and what we need to do now is substitute in that 14 that we calculated for our x value. So for measure of angle A, we're going to have 7 times 14 minus 11, and that gives us 87 degrees. Next we will have 5 times 14 minus 2 degrees. That gives us 68 degrees. And finally we will have 2 times 14 minus 3 degrees, or 25 degrees. You'll want to double check that this all adds up to 180 degrees. 7 plus 8 is 15, plus 5 is 20, carry that 2, 2 plus 8 10 plus 6, 16, plus 2 is 18. So 180 degrees. So check mark, yay, done. Woohoo! The next thing we have to do is figure out this angle y. What is y? Well, we know y is a linear pair to angle ACB. So we want to take 180 degrees minus angle ACB. So y degrees equals 180 minus angle ACB was 25 degrees. And we will get 155 degrees for the measure of angle y. So these are our 4 angle measures. The measure of angle y takes us into the next theorem that we want to talk about, and that is called the exterior angle theorem. The exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 non-adjacent angles. In this picture, it's talking about angle 1 as the exterior angle, and the non-adjacent angles are A and B. Non-adjacent meaning not next to. Angle ACB is the one that is next to angle 1, or its linear pair. If we take a look at, well, let's first take a look at the example we just did here. If you take 87, which is angle A, plus 68, which was angle B, you get 155. 87 plus 68 is 155, and that happens to be what angle, the measure of angle ACB was for our y measure. Let's go ahead and do another example with just the non-adjacent sides and that exterior angle measure. We are being asked to find the measure of angle PQS. So this angle measure here. We know by the exterior angle theorem that this equals the sum of these two. Writing that out, we have 3x plus 25 equals 2x plus 65. I'm going to drop the degree symbols just to make my writing easier and make it less confusing where everything goes. We need to solve for x, so we have to collect like terms. I'm going to subtract 2x from both sides to start. We're left with x plus 25 equals 65. Subtract 25 from both sides now because we want to get x by itself, and we're left with x equals 40. Substitute 40 in for x at angle PQS. So the measure of angle PQS equals 3x plus 25 degrees. Substitute that 40 in. We get 3 times 40 plus 25, or 120 plus 25 degrees, and finally 145 degrees is the measure of angle PQS. There is one more theorem in this section, and it's called the corollary to the triangle sum theorem. And this is for acute angles of a right triangle, and it says that they are complementary. Anytime you're given a right triangle, that means that angle A plus angle B are going to add up to 90 degrees, which makes sense if you think about it, because the triangle sum says that there's 180 degrees inside of a triangle. If we take away the right triangle, which has a measure of 90, we're left with 90 degrees. The remaining two angles have to add up to 90 degrees because that's all we have left to work with. So the measure of angle A plus the measure of angle B equals 90 degrees. Let's do an example. Oh, I forgot to write degrees on these. Let me add that in. This is a right triangle. So we have that 90 degree angle marked there. That's how we know it's a right triangle. And applying the corollary to the triangle sum theorem, we can then say that 3x plus 10 plus 5x plus 16. Those are two angles, and they add up to 90 degrees. Collect our like terms. We have 3x plus 5x, or 8x, and then we have 10 plus 16, which is 26, and that equals 90. Collect like terms still. We have to subtract 26 from both sides. We have 8x equals 64. Divide both sides by 8, so we can solve for x, and we get x equals 8. We are being asked to find the measure of each acute angle. Now we need to plug those back in. Let's label this A, B, C. So the measure of angle B is 3x plus 10 degrees. Substituting in 8 for x, we get the measure of angle B is 3 times 8 plus 10 degrees, or 24 plus 10, or the measure of angle B is 34 degrees. You can always subtract 90 minus 34 to get the measure of angle C, and you would get 56 degrees. But let's double check, because if we did this wrong, it's not going to be 56 degrees. But it's a way to double check, because angle C should be 56 degrees. Now applying the formula for angle C, we have 5x plus 16 degrees. Substitute in that 8 for x. We get 5 times 8 plus 16, which is 40 plus 16 degrees, or finally 56 degrees. And that matches up to what we came up with earlier, so that means our angle B has to be correct. That concludes everything from section 5.1. In this lesson, we just learned about interior and exterior angles, the triangle sum, which says that the sum of the interior angles of a triangle is 180, and then the exterior angle theorem and the corollary to the triangle sum theorem, which we just completed. That's it for the lesson, and I will talk to you soon. Thanks.